Hey guys, so let's continue this wireless session. We already understand about the different like uh, concept of the radio frequency. We understand what the frequency band, right? We understand about that. What is RF? What is the signal? How the channel is going to be used. Now, this time we just have to understand about the wireless architecture. It's the most important, right? You just have to know how basically wireless architecture is going to look like. So if I am going to be like little bit down, so we are discussing about right now about the wireless fundamentals. So we also have to understand the physical infrastructure connection of the WLAN, like AP, WLC, access port, trunk port, lag. What is a meaning of these all concept, right? Also, we have to understand about that AP and WLC management access connection, telnet SSH, HTTPS console, TACAX radius. So we'll understand one by one, but let's understand first the architecture, and then we'll understand by the AP modes. Okay. So in wireless domain, what are the key component is going to be required for any, like we are discussing about the home network. So in a home network, we know that we having some requirement, which is Wi-Fi router must be there. Those Wi-Fi router is doing the dual purpose. It's like the spreading the signals within the house, within the office. At the same time, this router is going to provide the connectivity to the internet as well. So it's like the acting as access point, and also it is acting as a pure internet based router as well. So is it the same thing is going to use in the companies? The answer is no. This is the home solution, and company having a different solution, that is the enterprise solution. So companies basically to deploy the wireless network, they purchase some product. Any wireless network, if you are going to deploy in the company, they require some products. So first product they are going to require, that is a WLC, and second is AP. So what is WLC? You might write here wireless controller. Okay, and what is the AP? That is a access point. These both are going to be a device. This AP must be a hardware. This AP must be a hardware. This WLC can be a hardware or can be a software device. Why it's a hardware, why it's software? So if you go and purchase the WLC, like you purchase the router, you purchase the switch, it is possible. But if you want to deploy the WLC image on the cloud or might be internal server, that is also possible. That is a software image. But AP basically it is always going to be hardware because it have to spread the signal. Okay. So how basically it is going to look like? So let me go and show you something about how WLC is going to look like and how the AP. So Cisco WLC, we are just talking about the Cisco. And if you go in the images, you're going to find this is WLC. You can see if you just click here, you can just see this is a service wireless controller. This is the model number of this device 2500, which is the service wireless controller. And in this device, basically, we can connect the multiple AP, but how it is going to logically and physically connection is going to happen, that's another story we have to understand. But you just have to think this is the something is a brain of the wireless system. Without this brain, you cannot run this wireless system. But this statement could be partially true, not 100% true, because we having some scenario where this device is even not required. Okay, so I'll explain that. But in all modern network, if you're having the very big network, very complex network, this wireless controller must be required. So this is the one device you just have to take a note. Now similarly we have something that is the AP. You must have seen this device. This must be in hardware, and you must have seen somewhere in the your office, somewhere in the railway station, somewhere in the airport, somewhere in the metro, where you are getting the free Wi-Fi signals, or in office you must have seen this. So why this is the required? Because this must have to install in some location of your office who going to cover your area to just provide the signals, right? So these are the AP, that is not the access point. Different models they have. Catalyst 9100, Catalyst, you can Cisco Aeronet, you can see 1560, right? Cisco, you can see 1142, right? These are the like 2700 different models we have, and this is the 1542 IE, and this going to be used in the different location of your office location or any other location. So let's start. I believe you understand the product. So WLC and the AP is the key component. Without that, you cannot proceed with the WLC. Means the any wireless communication. Now, I mentioned that one of the statement, this WLC is the key component. It is acting as a brain. But can I remove this WLC from my network? Still, I am able to give the wireless communication. The answer is yes. There is two type of the wireless. One is the AP, which is known as the autonomous AP. Okay. One is the AP, which is known as the lab, which is lightweight access point, right? So this is the lab, which is basically going to be lightweight. So if you are using the autonomous access point, no need of the WLC. No need of the WLC. If you are going to use the lab, you require the WLC, right? So this is two things again we have to understand. How it is going to be required, what is the key component, let me explain about that. So in your network, you must have the multiple floor, and might be your floor is going to be very big. So how actual this all network communication is going to be deployed within your entire floor, entire organization? What is the underlying concept is going to be happen, right? And how and where this WLC autonomous AP or lightweight AP is going to be configured, and it is going to be connected to the network. That diagram I'm going to draw. So just wait for a few seconds. Once it is going to load, I'll just explain how it is going to be happen. Meanwhile, you can see here, this is my wireless architecture. This diagram you can refer it. This is showing the wireless architecture. So how wireless architecture is going to be communicated? Let's suppose this is your office. This is your office, and many people are sitting here. You having a laptop, you sitting here, sitting here, sitting here, sitting here, sitting here, sitting here. These all are the user, different location. Different location, they all are there. Just give me 1 second. So I was discussing about like how the setup is going to be happen, right? In case of like this user need to communicate with the your office network, or might be out of the office network. Means what the user need. They are the users, they are the laptop. So what kind of access they are required? They need access of the internet. They need access of the internal network. If I'm talking about the internal networks or internal servers, basically this is the appropriate work, right? This is going to be internal server. So basically what is going to be happen, if this user, let's suppose this is the user, he is connected on this machine. Right now there is no cable connected, right? So if there is no cable is connected on this, so this is going to get the signal from this wireless media. So this wireless media keeps sending some signal, keeps sending some signal, keeps sending some signal. Likewise your home router, it's spreading the signal. So via the NIC card, wireless NIC card, it is going to capture those signal, and based on that, he will transmit the packet to this wireless, that is AP. You can see this access point. This AP further going to send this traffic to this switch. This switch might be connected with a multiple switch. Just forget about they having the multiple connectivity, and then it is going to connect to the one of the router. This is the router. So now my traffic is moving from this AP to switch, switch to switch, switch to switch, and then further it a router, and this router having the internet connectivity. This is my internet. So my traffic will move from this PC to switch to the router and router to the internet, and finally it is going to access the Google. Whatever the website you want to access, like the Facebook, might be the YouTube, whatever they want to access, that all is going to be accessible. This all is going to be accessible. Similarly, this is your internet connection. This internal network access means this PC want to communicate with this PC, or this might be your server, where you're just storing some kind of a data or database, whatever you're just storing. This going to be processed. This going to be processed again. This user is going to reach via the wireless to this AP. This AP is going to switch again. It's going might be the this way or this way. We understand how it is going to be happen, and then finally it will come to this AP, and this AP keep broadcasting the signals again, and it will reach to this AP, and this is how it is going to do the communication. So you can see, even I have to do the internal network communication, even I have to do the external network communication. In both of the scenario, my communication is going to be through, right? And when it is going to be through, we require the multiple devices in between the all communication. That is going to be required the router for the any internet communication. It is must be required. Along with router, switch also going to require, and third device is the AP is also going to be required. So if you're having any internet connection, router is must. Internal connection, you might not require any router if you're just trying to talk within the site. So this is how the architecture is going to look like. Now, here you can see in this diagram, we have the AP, which is known as the autonomous system AP. Okay. So what does mean autonomous system AP? So I explained that if I'm talking about the autonomous system AP, this AP basically not required any WLC. You're not finding any device here which is known as the WLC, which I explained. It's the key component, it's the brain, right? But it is not available in this entire topology. But you're having the AP, which is known as the autonomous system. So in an autonomous system, we do not require WLC. These autonomous system AP itself are capable to have the control connection, have the data collection, means the data connection. So they having the brain plus they having the intelligence, both they having, and they can do anything whatever you want to do that. So this is how it is going to be happen, right? So now we understand about the autonomous AP, which is going to look like in this way. If you have the lightweight AP, lap AP, then in that case you must require WLC. Let me show in the, probably will find the next architecture. So again, you see these are all the autonomous like the AP, they connected with the multiple switch, multiple AP, but they not required any kind of the WLC. But here you can see now we having a Cisco Meraki AP. This is the like Cisco AP Meraki solution they are talking. Similarly, we having the pure Cisco SD-WAN AC, means a Cisco wireless solution AP, which required the Cisco controllers. So in this case, your data plane is going to be local to the device, data plane and the control plane. So there's two things you just have to understand: data plane traffic and the control plane traffic. So what is the control? Control is actually a brain, means the decision is going to happen, and it's just forwarding the packet. This all basically available here. So you having the data plane, in this data plane you just have the different APs going to be communicate with the multiple clients, and if any decision required from central, like how the communication, how the intelligence is going to be inherit between this data plane, then it must be go through that switches to the wireless Meraki cloud controller, which is a WLC if we have. So this WLC is going to give the instruction how you should communicate to the network. So you can see one of the data and one of the management, which is the control plane. So a control plane, the traffic used to control, configure, manage, monitor the AP itself. Data plane, that is the end user traffic passing through the AP. That's it. That we have to understand. Means if I'm talking the control, it's the brain. Like you having the hand, you having the feet. So your brain is giving instruction, just up your hand. You're just going to up your hand. Your brain is going to say just down your hand. So instruction giving the brain, and you're just doing your up and down your hand. So this is how it is, a control is going to happen. And your hand, whatever doing, that is your data plane is happening there. Right. So I believe this is the about this autonomous system and the lightweight AP. And you can see here we having the autonomous system versus lightweight access point. So autonomous system AP does not require any WLC, but lightweight AP is always going to require the WLC. So what is going to be happen when we having the lightweight AP? We must have to use the WLC, and by using the WLC, basically you have to communicate via the CAPWAP tunnel. You have to communicate via the CAPWAP tunnel till the WLC. So what is a CAPWAP tunnel? So CAPWAP tunnel is something which known as, let me write it here. CAPWAP tunnel is CAPWAP tunnel, right? Which is going to create between the your lightweight access point and to the WLC. So what is the full form? That is known as the control and provisioning of wireless access point. Control and provisioning of the wireless access point. These are the terminologies which is known as the CAPWAP tunnel. It is a very secure protocol. It is a very secure protocol which is going to carry the all control traffic, real-time control traffic as an encrypted format from the access point till the WLC, right? And how it is going to work? That is going to initiate is a tunnel from the lightweight AP to the WLC, and that CAPWAP connection is going to be created. The tunnel is going to be established, and that CAPWAP is going to carry the all the required control connections, means control communication. But in the autonomous system, we do not require the WLC, and it is not required any kind of tunnel between the WLC and the AP. This is the key difference. So in autonomous system, they're simply going to connect to the switch, and all decision is going to, any packet is going to happen between these two devices they want to communicate. Decision is going to happen from the autonomous system itself. But in this lightweight, if we have two clients, they want to communicate, the all decision is going to happen in the control plane, like the WLC. This is the key things you just have to understand about it, right? And this is how you have to bring the CAPWAP tunnel, which is going to use the protocol port number 5246, 5247 data. One is going to carry the data, and one is going to carry the control traffic. These are the two things you just have to know about it, right? So linking the lightweight AP and the WLC with the CAPWAP. So even the CAPWAP, one CAPWAP tunnel is going to carry the data traffic, one is a control traffic. Only the port difference is going to be changed. One is the 5246, one is the 5247. And if you go here, there is a one of scenario. Let's suppose we have the two SSID, which is going to be broadcast is a single SSID. We just think about that. So that SSID 100 is going to communicate with the another VLAN, which is the behind the WLC. So first they have to make the reachability with the routing, or might be the having the same network, or might be the inter-VLAN network, or might be the another way of the communication. Your both subnets should be communicated. Once your subnet communication is there, means once both VLAN is going to have the communication, then only this VLAN 10 or 20 or 100 or 200 are going to make a communication via the CAPWAP tunnel. So routing is in place, then this is the layer 4 CAPWAP tunnel is going to be created, right? So you can see here again another scenario, multiple AP have the multiple CAPWAP tunnel via the switch. So these are the logical. Physical is always going to connect via the switch, and we just have the routing reachability, but logical is going to happen with the CAPWAP tunnel. Okay, so means if anything is going to be initiated, this AP must reach to the WLC via the physical, means AP, then the switch, then the WLC. They should all physically connected, but tunnel is going to be formed between these two is the logical, right? And through this all the data is going to be processed. So I believe you guys know about a little bit about the physical and logical. If not, definitely in the upcoming session I explain these all things. How is the logical, what is the physical? So physical is, you can just think about this way. Physical is means I'm connected physically, right? Logical is like something is showing to me how to reach to the destination. So you have seen on GPS. GPS is something when you start any destination, it is going to show the virtual path. This path you have to follow to reach to any destination. But when you have to drive, you have to take the actual road. That is a physical path. But your GPS is showing just all the possible route or all the possible way to reach to the any destinations. So you can see here how WLC functions. So now we have to understand the WLC. So we'll explain this WLC concept later stage. And for time being, we'll just stop this session because we just understand about the basic concept of the autonomous system. We understand the basic concept of the lightweight autonomous system. What is the key component of the like the any wireless media, that is a WLC, AP and switch and router, which case it is going to be required and when it is going to be required, that we understand. So in next case, we'll do the deep dive about the WLC. What is a WLC? How it is going to work? We discuss about the CAPWAP tunnel, right? And we understand how the lightweight tunnel is going to, how the loudweight AP is going to form the CAPWAP tunnel to WLC, right? So thank you so much. We'll connect again in the new lecture.